All right, good day, class. So our first lesson for our final term is about bipolar junction transistor or BJT. And then after which we're going to discuss the field effect transistor. So majority of our discussion on finals revolve around transistor. So in this lesson, we're going to discuss the construction schematic symbol of BJT, and then the basic BJT operation, and then regions of operation, and then how transistors work. So there is a link that I've attached here on how transistors work. So analogy siya on how BJT or how transistors work like a faucet, right? So just click the link after my discussion so that it's a very short click, mga 3 minutes siguro, so that you can kind of visualize how transistors work like a faucet or kanang gripo. Right, so let's start. So, unsa din BJT? So, the bipolar junction transistor is constructed with 3 doped semiconductor regions separated by 2 PN junctions. So, if you can remember some discussion sa diode, we just have the anode and cathode or the PN, right? The PN junction, PN material. So, these are dope, no? So, if you can remember, doping is the injection of impurities para ma-increase ang ato ang carriers, right? So in a BJT class, we have 3 dope semiconductor regions. So for example, kining NPN. So nasa tayo PNP no nga transistor. And these are dope. These are dope. So nag-inject ta diri, ga-inject po ta diri, and dira. Alright? And they are separated by the 2 PN junctions, kini nga junction. Ano nga na-create between the materials. And we call that as the base collector kini, and then the base emitter junction. So we'll discuss later nganong inaniyahang mga names. Okay, so for the application of BJT, this can be used in amplifying or as an amplifier or switching application. So it's either amplifier siya or switch. So there are 3 regions in a BJT. Okay, 3 regions or 3 terminals. And these are the emitter. So kanang naka-E dira, right? And then this is the material na kini nga part sa BJT ang heavily doped. It means mas daghan diri o gina-inject ng mga impurities no para mas mo increase pa jud ang current nato. Diba, if you can remember, ang doping is the process of injecting impurities so that the current will increase. So mas mo conduct siya. And among the 3 terminals, kining emitter ang iyahang heavily doped na material. The next is the base. So kaning nasa center, this is the base, no? Kining nga base terminal. And this is just lightly doped compared to the emitter, very light lang or very few lang ang gi-inject nato ani. So mas makita sa nato no nga ang pag-construct niya mas medyo gamay ang area sa tuang base. And then lastly, we have the collector terminal. This is moderately doped. So compared to your emitter, murag siya ang natong in terms of doping. Alright, so that is why kini nga junction diri, kini nga PN junction between your base and collector is what we call the base collector junction. And then this one is our base emitter junction. Okay, so it's very easy to remember the 3 terminals of a BJT are the emitter, base, and collector. Okay, moving on. So as I've mentioned before, there are 2 types of transistor. So we have the NPN type. Okay, kanang very straightforward NPN. Okay, ang majority carrier sa N is unsa man? Electron. And then for P, the hole, and then N again electron. So, excuse me. Alright, so first type is the NPN. Now, kung NPN gani class, dali na kayo siya hinumduman, no? Or any type for that matter. Kay kani siya is emitter, base, and collector. Actually, pwede na mabali ang imong collector o ang imong emitter because in any type of the transistor, ang collector nimo ang emitter will have the same material. Wala man tay NPP or PPN or NNP. Okay, so it's very easy to remember. So first is the NPN type. Now this is composed of two N regions, kani siya, atong emitter o nga atong collector, separated by a P region sa tunga. Okay, that is why gipangalan siya NPN. And then, muna siya ang construction nato sa NPN, right? And this is now our schematic symbol. So, kung magtanaw sa tong multi-sim class or Proteus or any circuit simulator, muna siya ang symbol nato for an NPN nga transistor. So, think of this as your node. Okay, muna siya ang node. And then, this is the base. And then, imuhang arrow is pagawas. Okay? And then, this is the collector. So, muna siya ang schematic symbol for NPN. And for PNP, the second type of transistor is the PNP type. So, balira siya sa NPN class because this is composed of two P regions. So, muna siya P sa emitter sa atong collector, separated by an N region, meaning ang N nato is katong base nato. Okay? So, our schematic symbol for that is bali lang sa ato ang NPN. Ang arrow nato is pasulod. Actually, when we were taking the board exam, ang the easiest way to remember ang NPN kay kung malibog pa mo, ang namin mnemonics for NPN. Pero sa una, medyo bastos to siya. So, ang wholesome na mnemonics nato ani karon is for N, para mas ma-remember natong arrow is nigawas. Okay, nigawas, N. Ang P is, ang arrow is pasulod. That is why we have P. And PNP. Okay? So, kung malibog pa mo, magtanaw mo ano yung schematic, how do you remember it? Diba? Sa arrow tamag, sa emitter always ta magtanaw. Okay? Kung unsa yung arrow, kung nigawas yung arrow, so meaning kini is N, ang E, P ang base, and then collector is N. Okay? And then kung kita po gani nga schematic sa emitter nga iyang arrow is pasulod, then this is P and P. Okay, para kung gasugod pa lang ka og learn ani ba, para mas dali nimo siya ma-remember or mas dali nimo siya kuan. And why does this matter? Because kung mabaligan ani mong NPN ug PNP type, mabali pod ang imong biasing class. And we're gonna discuss later unsa iyang mga specific biasing para mo on ang atong transistor. And lahi siya, of course, kung NPN o PNP, lahi na siya og pag-connect nimo ko kibali sa imong V bias. Okay, so it's important to remember. So these are the two types of transistor. Again, we have the NPN and the PNP type. Okay, so this is now our basic BJT operation. So, ang pinaka-basic na operation, there are three operations na known for how the transistors work. Pero let's first discuss the basic BJT operation. So in this operation, one PN junction of a transistor is forward biased. Okay, whereas the other is reverse bias. Okay, meaning naay junction diri class nga naka-forward, naa sa junction nga naka-reverse. So think of this as two parts, no? Kini siya is ato ning i-bias. Mura siya diode ba? I-bias na tong isa ka PN, i-bias mo na tong isa ka PN. Kini bias ng isa ka PN diri, i-bias po din nato siya. Alright, so if you can remember, natay NPN nga type, nasa type PNP, no? So, how do we connect now the bias class or the voltage source nato? Ang forward bias is always the emitter base or the emitter junction. Okay, para mas dali ninyo hinumduman, pwede ra isa inyong hinumduman ang emitter. Okay? Ang emitter should be forward biased and ang reverse biased is the collector. Right? This is general because when you have NPN and PNP, kanira gyapon ang rule. The same rule applies. Ang emitter nimo is always forward biased and ang imong collector is always reverse biased. This is the basic BJT operation. Now, let's first look at NPN. So sa NPN, ato sa siyang i-isolate kumbaga class. Kining emitter junction nato, meaning emitter and then base, ato daw ni siyang i-forward bias, right? Okay, so how do we forward bias a junction? If you can recall the midterm discussion, dapat by now, murag second nature na sa inyo ha. Forward bias is katong N or the negative terminal, dapat connected po siya sa negative terminal sa imuhang V bias. Now, atong V bias diri class is named as VEE. Okay? For the emitter, of course, VEE, and then for the collector, VCC. Okay? So let's first look at the emitter junction. So kano saan nato nimo forward bias gani, since this is an N material, dapat connected siya og negative, right? Actually kana ra imong needed. Kay mabali mo follow naman din ang uban. Imong P should be connected sa imong positive. Okay, so meaning this is correct. Our VEE now is the V bias of our emitter junction. It is now forward biasing the emitter junction. So sakto no, kini nga part sa ato ang BJT, kini nga junction, is forward bias. Okay, check na ni, naka-forward bias. Now, let's take a look at the collector junction, kini nga junction. Alright. We need to reverse bias this junction. So, unsang dali, dapat opposite siya. So, atong N here should be connected sa positive. Right? And then P is connected sa atong negative. So, indeed, it is reverse bias. Okay, so this is how you connect your BJT to operate in the active region. So, kani siya is what we call the active region of operation class. We'll discuss that after this slide. No? So, let's go sa PNP class. Kung unsa po diyang difference sa NPN. Ganong maingon ko nga, you have to make sure kung unsa gid siya nga type sa imong transistor because that's where your biasing depends on or the connection depends on. Okay, so again, unahan na to ang emitter junction. So for the emitter junction, kana siya, no? So we need to forward bias it. How do we forward bias it? Ang P should be connected sa positive. So sakto, no? And then N is connected sa negative. Mo ni atong VEE. So meaning this is forward bias. So tanawa, sa ato ang NPN, negative ang left, di ba? Positive ang right. So sa ato ang PNP, ang nasa left is ang positive and then ang nasa right is ang negative. So, lahi siya connection but both are forward biased in relation to its type of transistor. Okay, mo na ningon ko nga dapat dili gid nimo mabali ang iyahang pag distinguish sa type of transistor. Kay mabali imong terminal dili na ka maka-forward bias or maka-reverse bias. All right, let's have the collector junction. Okay, this is now our collector junction. Now, we need to reverse bias this one. So, atong positive should be connected sa negative. Ang ato ang negative should be connected sa ato ang positive. So, this is our VCC. So, meaning this is reverse bias. Okay, so these two types of transistor class satisfy the condition of the basic BJT operation, wherein our emitter junction is forward bias and then our collector junction is reverse bias. So both of this type of transistors class operate in its active region. All right, so let's take a look at the theory behind that. So kung atong tanawon class, ang atong example ani class is a PNP. Example na tag PNP actually, ang NPN na to is balira na siya no ang ihang flow sa current. Alright, so ato sa siyang i-isolate class, di sa nato i-consider iyahang isa ka junction, no? Tanawon sa nato ning emitter junction, right? Kini atong tanaw na ang PNP. So, iyang emitter junction is, iyang majority carrier sa P, of course, are holes. Kini mga positive dire. And then, ang iyahang majority carrier sa N are electrons. Okay? Kaning to nga. So, that means, ang ato ang pag-connect class is positive, negative, no? Kani siya. Okay. Na-forward bias na ni siya. Okay, unsa kay mahitabo sa forward bias? If ma-forward bias na, ang ato ang syempre positive dire no, so ma-repel niya ang positive. Tanang negative class, tanang electron will be attracted to this side, right? Because this is positive. Kini nga side, kini nga side. So since this is a positive terminal sa imong V bias, tanang electron class sa imuhang N o sa imong P, kini nga electron dire, ang tendency niya is mo adto siya sa imuhang left, right? And then your hole, which is the majority carrier, will have will go to the opposite direction. That is why nasa arrow diri nga ang majority carrier, which is the hole, will be moving to the right. Tama? Kay ma-repel man niya imuhang positive diri. Okay. So that is why kini nga junction very thin na lang ni class, no, kay kumbaga nanabok na ang mga charges ba kay naka forward bias man ta, if you remember the theory behind the biasing of the diode. Okay, so meaning na nakay kuan dira, na nakay current dira nga flow. Again, we are considering here the conventional flow, the flow of holes, dili ang electron atong i-consider, no? Pero actually we know that ang electron man jud ang ga-move, no? But the majority carrier atong i-consider, the hole ang atong i-consider, no? So atong current will be flowing from left to right, no? With respect sa ato ang emitter junction. Now let's go sa ato ang second figure, which is the another PN junction for the collector junction nga naka-reverse bias. Alright. So kung naka-reverse bias siya, atong P dire class is connected sa negative, right? And then ang ato ang N is connected sa positive. Okay. So morning baga kay siya dire class because remember when we are reverse biasing a diode, di mo maka-create siya og depletion region tungod kay na-attract imong P is going to this side, na-attract man siya ani nga side, kining negative. And then your N electron is attracted to this side. So naa kay mabuo dira nga depletion region, no? But because kini siya nga part sa imuhang BJT, sa imong transistor, the move naman imong majority carrier of ang hole nimo, no, to the right. Now, your hole here in the collector junction is also moving to the right. Okay? So, ang minority carrier with respect sa imong N nga region sa tunga is moving to the right as well. Ang hole nimo is moving to the right, attracted to the negative side of your V bias. So, wala siya nagsangka class in terms of the flow of your hole and electrons. For the holes, whether it be the emitter or the collector junction, all the holes are moving to the right. Pahalag mo kaingon ka nga na siya'y na-create na nga depletion region, ang imuhang holes are moving to the right. Okay? Because ang holes, again, attracted man siya aning negative side, no? Your negative side is naaman diri o kana o kani. So, of course, imong hole is moving to the right. And your electrons also attracted sa positive, so it will move to the left. It means that your whole current actually is just moving to the right. So, munang imuhang current of your emitter is moving to the right, and then your collector is moving to the right as well. And then, nakaigamay kay nga current sa imong base class nga padulong sa ubos. Okay? So, yan lang gibutan diri, majority carriers are holes moving to the right. Minority carriers, kini nga mga minority, no, minority na ni sa gikan diri, oh. will be moving to the right as well. So all the holes again are moving to the right. So this is now the flow of a PNP transistor. Okay? Now, how about sa ato ang okay, diri sa ta sa schematic symbol niya, no? So, dali ra pud kay hinumduman class because your PNP, di ba, ayahang arrow is pasulod, P, pasulod. So, ang iyahang emitter current is actually going to the node. Dili siya pagawas sa node, no? So, imong current, imong hole diri is padulong sa right, no? So, kung tanaw na to, kani nga schematic symbol, ang iyahang current is musulod ka dira, right? And then, yes, again, think of this as your node, no? Pag sulod niya na nga node, murag na-distribute siya sa imuhang base, and then dito sa imuhang collector. Alright? So, I hope na imagine ninyo. So, ang majority good class sa current is from your emitter. So, it's actually given by this equation, no? So, tanaw na to class, kung kamao ni siya nga node, again, nisulod ang imuhang emitter current dira, ayha din siya ni-distribute sa IB o IC. So, your IE, which is your emitter current, is just equivalent to the sum of your collector current and your base current. Okay, so take note of this expression. So, it's always gonna be this way, class. So, imong emitter current is always the larger value than your collector or your base current. Okay. So, later on, I think sa next lecture, mas in detail pag nato ang pag-discuss aning emitter current, collector, and base current. Okay, unsa gid ilang relationship specifically. But for now, kabalot ang atong emitter current is the largest current, and this is the sum of your collector and your base current. Right? So let's go sa NPN class. Okay. So sa NPN pod class, ang ato ang whole gyapon tong istorya na ang whole nato nga flow is pa left na pod siya, bali siya sa PNP. No, kung gaganina ang ato ang whole is moving to the right because it's attracted again to the negative, kina-attracted sa negative. Ang ato ang NPN is padulong po siya sa left. No, ang mga holes class kay padulong siya sa left because naaman diri imong mga negative. Okay, same ra siya og concept sa imuhang NPN katong kaganina sa mga carriers niya per junction. If you're going to analyze that per junction, so same ra na siya. So we will have going to the left again, among no, wala. Nag-record. Okay na. Maputo lang siya. Pwede ra dire dyan. Sige. Sorry class. Okay. So, wait lang. Okay, so our whole current class will be moving to the left. No, as I was saying, it's opposite to your PNP type transistor. So, of course, bali pod ang iyahang current. So, again, it's easy to see, no, because your arrow here is padulong siya sa gawas, no? So, ni gawas, NPN type. So, again, think of this as your node. Kaganina, atong node, ang emitter current ato ni pasulod, no? Then, ayha siya ni distribute. Right? So, sa ato ang NPN, ni gawas po siya diri. Paana siya? So, meaning, atong current sa base DI is pasulod siya sa node. Ang IC po na to is pasulod sa node. And then, ang katong major current na dayon niya is, or the largest current value, is the emitter, ni gawas siya. So, in this schematic class, we can see that the relationship is still the same. Your IE is still the sum of your collector and your base current. Alright? Kay pagsulod niya dira sa B, pagsulod sa C, pag total ana niya class, ni gawas na din siya as your IE nga current. Okay? So, dili siya, in terms of your relationship of your current, whether it be PNP or NPN type of transistor, your emitter current is always gonna be the sum of your collector and base. So dili na mo kailangan malibog because dili lahi ang ihang relationship. It's always gonna be the same for both type of transistor. Okay? It's just that ang difference na nila is your flow of your hole and electron. No, ang flow sa imong kuryente opposite siya sa each other. And because it's opposite to each other, ganong opposite siya sa each other because your biasing is different because of your type of material nga nag-make up sa imong transistor. Okay, but again, it's the same. Your emitter current is the total of your collector and base. Okay? Sige. So, katong gi-mention ganina class, this is the basic BJT operation, no, where one is forward bias and then the other is reverse bias. Now, let's go to the 3 types of regions of operation class. So, katong gi-discuss na to kaganina, it's actually what you call the active region. Mag-mention na ako. This is where your transistor operates as an amplifier. Meaning, kaniday nga connection class sa atong BJT, kaning NPN nato diri nga gi-connect nato or gi-bias nato siya in this way. Kani siya. It means that we are using our BJT as an amplifier. So if we connect more mga components class, ang output nato ani is an amplified output, meaning kung it could be an amplified voltage or current, but since proportional naman sila, no, so that's the application. It could be it is an amplifier, so ni-amplify siya sa imong signal, sa imong input. Okay, how do you know gani nga it's an amplifier? Your output is greater than your input. Okay, usually ang mga application ani kay kanang sa ato bitong mga speaker, for example, hinay di ba hinay kay tagtingog sa atong nag-input sa microphone, for example sa atong voice, and then sa speaker madunggan siya sa, for example, sa tibuok room. So that's the kind of amplification ni mga application. So imong voice which is a very small amplitude or imuhang unsay layman's term ana gamay kayo siya og kanang voltage or current, pag abot dito sa speaker, ni-amplify iyang signal, mas sidako siya, mas madunggan siya. So that's the kind of application, one of the applications of a transistor. So again, kato atong gi-discuss kaganina, it could be used as an amplifier. Okay? An active, that is where ang region of operation based on the biasing is an active region. Okay, the other 2 regions are the saturation region and the cutoff region. Now, both of these regions, class, kung mo-operate ang transistor in these regions, ang atong application na is switch. Okay, but ang difference nila is when the transistor operates in its saturation region, naka-on siya nga switch. Okay, and then kung nag-operate po siya at cutoff region, naka-off na siya nga switch. Okay, so as in wala gid siya gaandar. Murag nga na ba? Murag ka ng ideal diode nato nga on-off. Okay, open close nga switch. Okay, so let's discuss in detail siguro in terms of the biasing. How do we bias all these regions? Before anything else, kini akong link ang gihatag. So please take time to watch this video. Di lang nako i-play dire. But watch it at your own pace or at your own time na lang. So this is a very good video because it shows the analogy of how transistors work like a faucet, no? So kini imong knob diri sa imong gripo, mo na imong control na mura siya mo equivalent sa imong base. And then your kini nga mga nodes nato is it could be kining emitter and your collector or vice versa, no? So, kung ato ning i-on ang faucet, class, okay, on atong faucet, mas mudaghan ang tubig nga mo flow sa, no, from your pipe, no, padulong dito pagawa sa imong gripo, kay bali, ana. So, the more ka mo tuyok sa imong knob or sa imong gripo, then the more water gid pod ang mogawa. So inga nagyapon ang concept sa tong transistor. The more ta mo allow or the more ta mo tuyok kibali sa to ang base, the more na to i-bias siya or ang value sa to ang input bias, the more pud ang current nga mo flow sa ato ang emitter to collector. Okay? So yan na yung concept. And tanaw lang ninyo nga video, mas na mga animation dito ay diri nga video. Right? Okay, so this is now the summary of your region of operation for your BJT, for your transistor, no? So, ato na-discuss ko ganina is the active region. Ang emitter junction nato, yun sa nato siya pag-bias, forward bias nato siya. Ang collector junction nato is the reverse bias nato siya. And again, sa man ang application ganina na we use that as an amplifier. So again, how do we connect that? Kini siya kung mga example class, naka-take note diri ha. This is only for NPN. So, mo na akong isi-work sa inyo ha later. Unsa po din connection for PNP. Actually, nanana sa kong notes ganina. Okay, so this is na the connection no, for your active region akong discuss ganina. Your N, para ma-forward bias siya, dapat naka-connect siya sa negative terminal. Okay, mo nitong negative terminal, the shorter leg of your voltage, V bias. And then your P, connected sa imong positive. So, naka-forward bias ang imong emitter junction. For your collector junction, dapat i-reverse bias nimo siya. So, again, imong N connected sa P, imong P connected sa N. Okay, reverse bias. Okay, let's go to our saturation region. So, unsa pud atong biasing para mo operate ang ato ang transistor in its saturation region. So, ang imurang balihon ana class, from your active region nga connection or biasing, kining collector junction. So instead of reverse bias siya, ato siyang i-forward bias. Alright? So tanawan, nabalira siya, di ba? Imong positive is nasa taas sa active, but for your saturation, ato na siyang gibali. Negative ang sa taas. So that this junction, collector junction, will be forward biased. Right? Because this is your N and this is negative. So naka-forward bias ng ato ang collector junction. And ang application na niya is again, it will serve as a switch nga naka-fully on or naka-fully close ang imong circuit, right? Okay. So let's go to our cutoff region. So for cutoff region, for the transistor to work on its cutoff region, ang duha ka junction class ato nang i-reverse bias. Okay? So basically balira gyud siya sa saturation region. So naka-forward na no, ang cutoff nato is reverse. So still it will work as a switch but naka-off nga switch. Okay? So kaganina forward man no. So karon ato na siyang i-reverse. So balihon na nato class, naka-reverse. Okay? Ang N dire connected sa positive. Ang N connected sa positive. So reverse bias na siya. So it's easy to remember, no? Ang active nato is forward reverse. Basta emitter junction na relative to emitter junction nga connection. Ang saturation nato region is both forward bias. And then for cutoff region, both reverse bias ang duha ka junction. Okay, so again, this is just the connection for NPN. Okay, I leave the PNP connection to you. So this is gonna be your Seatwork. So you need to tabulate the difference between an NPN type and PNP type transistor. So you need to write, dili ko masugot og naka-type na siya class. Dapat i-write gid niyo sa papel. So here I've already tabulated, pero if dili gani maigo sa inyong papel, then you can just tigi-tigion na lang ninyo siya pagsulat kung dili siya klaro sa isa ka picturean aning table kay mag-draw man gud mag-circuit, okay? So for NPN and PNP, you need to write or you need to draw its construction, say construction niya. Then schematic symbol, actually dili tanan sa akong slides. But I won't be giving the slides to you until mahumaning Seatwork. Alright, so again, schematic symbol sa NPN, PNP, and then what will be the circuit for each region of operation. So unsay connection niya sa active, saturation, and cut off. For PNP, actually gihatag na nila ako. For PNP, what's the connection for active, saturation, and cut off? Okay, so i-draw ninyo class. So, actually, mo accept ra ko nga pwede naka NPN, nakaklaro jud siya nga NPN, or pwede pod katong symbol nga ana. Okay? Basta ibutang ninyo ang iyahang terminals. And then unsay connection nimo diri sa imong V bias baka ha. And then of course you have to name the V bias, no? Wala lang ni siya name, but this is your VEE. Basta sa emitter gani nga bias VEE, sa collector nga bias VCC. All right, so this is gonna be your secret. This is very easy, and the deadline for this is on Friday, 5 p.m. So I'm gonna open the Seatwork today. So again, reminder, this is handwritten and this is posted on our Google Classroom. So you have to upload. Kung need mo upload og more files, more image para mas maklaro yung answer, then you can do so. Okay, so total points for this is 20 points lang because it's very easy. Okay, and then our next discussion will be focusing more on the configuration, BJT configurations. If you want to have advanced reading, then you can read these topics. Nasa tayo mga working equations anin, mga characteristic curves, and mga circuits. And then after we discuss each configuration, I'm gonna give you your first laboratory activity for the final term. So that's it for now, and hope you can submit your Seatwork on time.